everyone. In this video we're going to talk about how to solve a differential equation when given an initial condition. So in this case here we're given this dy dx is equal to the cosine of x times e to the y plus sine x, and we know that we're given an initial condition that y is equal to 0 when x is equal to 0. So in order to solve the differential equation, what that basically means, what we're going to do is we're going to find the specific solution. We're going to find the function whose derivative is equal to this cosine x times e to the y plus sine x. But additionally, that function must go through, in this case here, the origin. Y must equal 0 when x equals 0. All right, if we're looking for a general solution, that usually means that we don't have this initial condition here, and we're just finding it, with some constant of integration known as c. Okay, but in this case here, we are given an initial condition, so we are looking for the very specific solution. So before we can do anything else, we have to separate our variables. That means that we need all of our y terms on the left side with this dy and all of our x terms on the right side with dx. All right, and the problem we have right now is right here I see y plus sine x in my exponent. So before I can do anything, I'm going to have to figure out how to separate up that exponent so I can move the y to the left side of the equation. So what we're actually going to do here is we're just going to rewrite this using some of our exponent rules. We're going to say that dy dx is equal to the cosine of x times e to the y times e to the sine x. Okay, what this means here, if we're adding our exponents, that means that we must have multiplied like bases. So all I did is go back to create two like bases, e to the y and e to the sine x, and now we can take that e to the y and we can divide it over to this left side. So if we sort of rewrite this with all the y terms on the left, we're going to get dy over e to the y is equal to cosine x e to the sine x dx. All right, and now that we've separated our variables, the next step, oops, I forgot the x here for the cosine. The next step is always going to be to integrate. So I'm going to take the integral of the left, the integral of the right, all right, and we're going to take each antiderivative here, and then we'll solve for c. So before I do anything else here, I'm going to kind of rewrite this one on the left. I'm going to call this the integral of e to the negative y dy. And on the right, I'm probably going to need some u substitution here. Maybe I can see that this cosine x simply was the result of the chain rule when applied to e to the sine x, but maybe I have to use the substitution. So I'm going to go ahead and go through the steps just to be safe that everybody understands what I'm doing here. So I'm going to go ahead and let u equal the sine of x, which means that du is going to be the cosine of x dx. And so right away, this turns out to be very, very simple substitution, because I can now say this is just going to be the integral of e to the u du. Okay, so on both the left and the right, I end up with some simple antiderivatives, some simple integrals that I have to take here. So remember, the antiderivative of e to the u is just e to the u. In this case here, though, we have a negative y, so we're actually going to get an antiderivative of a negative e to the negative y. And on the right side, we have just e to the u, so we're going to call that e to the u plus c. All right, and now I'm going to go ahead and say that we have this negative e to the negative y is equal to e, I'm just going to plug back in for u, so that'd be e to the sine x plus c. Okay, so the next step now is to go ahead and use our initial condition. So again, I know that y is equal to 0 whenever x is equal to 0, so that means I have a negative e to the 0 is equal to e to the sine of 0, which again is just 0, plus c. So this here is just going to come out to be a negative 1 is equal to 1, right? E to the sine of 0 is 0, plus c. So I'm going to get a negative 2 is equal to c. Okay, so again, as soon as you integrate if you have an initial condition, the next step is to go ahead and find C right away. All right. So now that I know what C is, I can go ahead and plug it in. So I'm going to go back to this equation here. I'm going to say we have a negative e to the negative y is equal to e to the sine of x minus 2. And in order for me to come up with my particular solution, I need to get y alone. I need to solve for y now. So in order to do that, the first thing I'll do is just get rid of this negative right here. I'll divide that negative over. And so I'm going to get e to the negative y is equal to 2 minus e to the sine x. And now I'm going to take a natural log of both sides. So on the left, I'm just going to get a negative y is equal to the natural log of, this is going to be 2 minus e to the sine x. Okay, again, notice when you do your natural log of both sides, this is not natural log of 2 minus natural log of e to the sine x. Right? I'm not distributing natural log. I'm taking natural log of the entire side. Okay, and the last thing we have left to do is to divide the negative over. So we're going to get y is actually equal to a negative natural log of 2 minus e to the sine x. And that there is our particular solution, or our specific solution, to this differential equation when given this initial condition. So what that means is that this function here not only goes through the point 0, 0, but if I differentiate with respect to x, I should get cosine x times e to the y plus sine x. Okay, so I hope this video helps. Remember, this is the process anytime you're solving a differential equation. Right? First thing you have to do is separate the variables. Make sure you show the integration symbol. After you've integrated, solve for C. Then plug C back in. After you've used your initial condition to solve for C, plug C back in and solve for Y. Okay, that would be the final solution right here. So like I said, I hope this video helps, and I'll see you in the next one.